So we are done with the three laws of motion and what are the definition of forces. So we have to kanang kuan atong review atong laws of motion. So the first law of motion states that if an object is at rest, it will remain at rest, and if an object is in motion, it will move continually at constant velocity. Okay, constant speed. So that is the law of inertia. The next is the law of acceleration. So law of acceleration states that if there is a net force acting on an object, the body will accelerate. And the third law of motion states that if object A is exerting a force on body B, so in that is the action force, and in the body B will react by also exerting a force on body A. That is the law of interaction. So these are the action reaction forces. Okay, so we have to apply these three laws of motion in physical systems to to have a knowledge of dynamics of something like a physical system. Okay, so first, before doing the application of Newton's law, so I have to insert something because this is very important, especially when dealing with dynamics or calculation of the dynamics of physical systems. For example, I mean, this is called the free body diagrams. So free body diagrams, so just like what we did on the kinematics in 1 at saka 2 dimension, we represented any body by a point or just a single dot lang to to represent a the object. Okay, so that is called the particle model. So we have to get that idea, the particle model, in module 2. So that is the kinematics. Okay, so how to make a free body diagram on the eye? So free body diagram or FBD, first is Newton's first and second laws apply to a specific body. So at the beginning pa lang of calculating dynamics of physical systems, you have to decide first kung unsa man to na object ang you have to calculate the dynamics. So there are sa usa ka system ang good, there are two or more objects na kanang ga-interact, 'di ba? So just like sa imuhang just like we have a like table, tapos na ako'y object sa taas. So na ako'y sa akong isolated system, this is my system, na ako'y duha ka object. So we have the table and we have the object nga naa sa nakapatong sa table, 'di ba? So you have to decide kung kinsa nga body na imong gi-refer o what are your uh, kanang unsa man ang imong body nga imong ka-calculate ang dynamics. It could be the table or it could be the object nga naa sa table nga nakapatong on the table. Okay, so the second rule in making a free body diagram is first you have to include after after you decide kung unsa na nga object or body ang imuhang calculatan og dynamics. So the second one is you have to think of the forces acting on that body of interest or object of interest. So katudang mga forces acting on the body. On ha, from the word on. So nag-act sa body of interest or the object of interest na imong gina decide at the beginning of the calculation. Okay? Then the third one, the very last one is free body diagrams are very important to eliminate all the irrelevant forces. So katurang mga forces on the object of interest na imong gina-decide at the beginning ang anaa sa free body diagrams to to eliminate all the mga forces nga wala naman sa acting on that body of interest or the object of interest. So we have to focus only on the forces acting on the object. Okay? So ang free body diagrams are needed always o dapat na na siya always nag-draw mo because it will help you identify unsay mga forces nga nag-act on the body. Okay, mga relevant forces I mean. Okay? So, yeah. So for example, we have to draw a free body diagram below. So, draw a free body diagram or FBD of the following situations below. So the first situation, two crates A and B sit at rest side by side on a frictionless horizontal surface. So we have here the horizontal surface. Then this is your mass A, ay crate A at saka crate B. So side by side man siya, di ba? So the crates have masses MA and MB. A horizontal force F is applied to crate A. So we have F here, applied force. So we can put this one as FA, the applied force. And the two crates move off to the right. So they are moving together and this, in this direction. So we have to draw a free body diagram for both of the crates. Okay? So for crate A muna tayo. So crate A. So si crate A, so we can put crate A like a point, diba? Because of the particle model. So what are the forces acting on our object of interest? So which is our crate A. So unsa man to? So we know nga naaman siya sa frictionless horizontal surface. Therefore the surface will exert a force on the object A. So that is the normal force. So we have the normal force. This is the force exerted by the surface on the object A. So that is the normal force, diba? Then what else? What are the forces acting on crate A? Then we have also the weight. Remember that a body's weight acts at all times. So as long as you are on the Earth's gravitational field or even sa Mars or sa Moon, you still need to put the weight of an object as long as it has masses, 'di ba? So that's why gina-specify gyud siya nga naay masses MA at saka MB. So that is pointing downward. So this is the weight, this is the force exerted by the Earth on crate A. Okay, so you have to take note na kato mga forces on the crate A. So you will not you will eliminate all the forces nga wala nag-act on crate A. Okay? So what else? Of course, si applied force, 'di ba? Kay nag-apply man siya og force ni crate A. So you have to put also the force on crate A. So imo siyang iana diha. So force applied on crate A. So this is the force applied. What else? So naa pa ba? Okay, so always take note the kaning particle model. So the point which represents our object is actually in, if ato na siyang ibutang sa coordinate system, is just like our origin. So that's why our vector looks like this one. Okay? So you can put naman here FA pero masindot if paana siya, meaning ang imong crate A is nag-apply siya, the applied force is exerting a force on that direction of your crate A. So what else? Is there any force pa? Yes, of course, napay forces. So remember, kay since yung crate A at saka crate B mo is rest side by side, so kung pag-push nimo sa duha, so what will happen is this one. So ito yung crate A mo, di ba? Ang crate B mo. So of course, by Newton's law of interaction, kay since na may applied force here, 'di ba? So the force between A and B are also from the action-reaction forces of the law of interaction because they move in the same direction. Because why the B or the crate B move in the first place even though hindi siya yung gina-apply niyang force. And then we know from the fact that your crate A and crate B are at rest side by side, so we can take note that there are forces interacting between A and B, di ba? So that is the law of interaction, the action-reaction forces. So the force exerted by B on A, kasi B on A ta ha, we have to take note on A, so not by A. Okay, so on A lang ta. And what else? So that is going paana, 'di ba? Kay that is the force exerted by B on A. And then also there's according to the law of interaction, apud siya other forces which has the same magnitude. So this is the force exerted by crate A on crate B. Okay, they have to exert forces on each other because they are side by side. Okay? So, kung ato na siyang ibutang sa ato ang free body diagram, so what are those action-reaction forces can we include to the free body diagram of A, FBD of A? So, that is only the FBA. So, ito lang, which is going dito. So, this is the force exerted by the crate B on crate A. So, ito yung free body diagram on crate A. How about on crate B? So, crate B tayo ha. FBD on crate B. So, we have to include all the forces acting on B. So, we have to put B as a point. Then again, since yung crate B mo is in the frictionless horizontal surface, so wala siyang friction but meron siyang normal force. This is the normal force, which is the force exerted by surface on crate B. So can I just put this one as NA to because they are not the same man. Okay, so generally they are not the same value, so we have to specify na normal force ito ng B at saka A respectively. Okay, so how about the weight? Again, meron ding weight yung crate B mo kasi meron siyang mass in the first place. So we have the weight of B. This is the force exerted by the earth on crate B. Okay, so we have that one. So they are both crates have na siya normal forces and weights. Okay, so what else? So what are the forces? So how about yung forces acting on the B because of the action-reaction forces or the law of interaction? So yeah, we have to include na the force exerted by crate A on object B, which is going in this direction. So this is the force exerted by A on B. So meron pa bang applied force? So wala na kasi yung applied force is directly applied to the crate A, hindi sa crate B. Okay? So yeah, I think that's the free body diagram for crate A at saka ni crate B. Okay? So how about yung second example natin? Okay, so our second example is a physics book at rest on a frictionless horizontal table. Draw a free body diagram of a physics book. Draw a free body diagram of the table. So meron tayong two object and we have to draw FBD for both objects in our system. So can I just draw our system? So we have the table here. So I don't know how to draw this one. So this is the physics book. Okay. So yeah, that's just a table. So we have to draw separately the free body diagram of the physics book at saka ni table. Okay, so for physics book, at rest man siya. So what are the forces interacting on the book? What is the free body diagram of the book? So since at rest siya at walang applied forces, so what are the forces man? So of course the weight. We know that weight of the book. What else? Of course the normal force, which is the force acting on the book by the surface. Okay, book. Ito lang. Then we are done. How about for the table? So we can represent the table as a point. Okay? So the table is of course na ay weight, 'di ba? So weight lang yung naasa kanya, weight interacting on the table. So you can actually also sa kana iyahabitang mga legs, but we are actually only referring on this one, the surface of the table. Okay? So that is why weight lang table yung nakasali sa free body diagram ng table. Okay? So yun lang. Last example for free body diagram. So a person pulls horizontally on block B, causing both blocks to move together as a unit. While the system is moving, draw a free body diagram of block A and block B if the horizontal table is frictionless. Okay, so we have to draw na pod. So nado ko na ko'y A na nakapatong ni object B, tapos gi-pull si object B, then i-move sila together as a unit, and they are both on the horizontal table. So we have to make a FBD, make an FBD for block A and block B. Okay, so for block A, so what are the forces interacting on block A? Of course, naagid siya yung normal force, di ba? Kay since parang si A nakapatong ni B, and si B, we know that block B has a surface here, okay? Di ba? So therefore, naman siya sa surface imong A. Then therefore, naa siya yung normal force. So this is the normal force of your A. Okay? What else? What else? So we also have weight, because weight acts at all times. So weight of A, which is equal to mass times the acceleration due to gravity. What else pag yun? Napa ba? Naapa ba? So basically, naaman sila duha, di ba diri? So basically na ay force, law of attraction ng interaction diri, di ba? So we have the force exerted by B on A, at saka we have force exerted by A on B. So yung force exerted by B on A, ito yung normal force. Kasi yung normal force ng A, kasi yung object A mo is nakapatong sa surface ni B. So yung B is considered as your surface. 'Di ba? So basically yung force exerted by B on A is actually the normal force of A. Okay? So that is why wala siya diri nga kwan, because he is considered as the action forces or your action forces. Okay? So what else pa man? So naa pa ba? So take note na yung system mo is moving together as a unit. So meaning nag-move siya together even though yung gihatagan na og applied force is si B. So basically kung walay friction diri sa imuhang B, what will happen is matagak unta si A. Diba? Kay because you pull B and wala may mag-hold together ni A ug B. Diba? Para si A kay magstay sa ibabaw ni B. Okay? So ang atong buhaton is we have to assume nga dili ni siya frictionless ang surface ni B. Ang ingon man ang ira man giingon if the table is frictionless. So basically the surface of B is na siya friction, because if wala siya friction, what will happen if imong i-pull si B, matagak si A. Di ba? Kay wala may mo hold ni A, wala mo glued together ni A to B ba. So that is why dapat na siya friction. So the friction is kay since dito man iyahang iyahang paghulog kay dito man, di ba? Dito man iyahang paghulog. So therefore iyang friction is going in this direction. So this is the friction force on A para ma-avoid ang paghulog niya na in this direction. Diba? Kung imong i-pull, mahulog mo siya paan na. So para ma-avoid niya ayang pag-fall, so dapat yung friction is moving in this direction. Okay, friction on A. Okay, so how about for B? So what are the forces on B? So we have to again represent our block B as a point using a particle model. So again, we have to put the weight of block B. And what else? Frictionless mo yung table, so wala siyang friction. Pero meron siyang applied force, which is the pull. Pag-pull ng block B, so going in that direction, this we can call this one as the force applied. What else? Excuse me. So what else pa? So how about itong force exerted by A on B due to the uh, interaction, due to the action reaction forces. Okay, so we can include that one. So this is the force exerted by A on B. What else? So take note na dapat i-overlap lang yung natin, yung mga forces on the same say direction. For example, if downward yung duha ka forces, so we can overlap them, or para ma-distinguish nato siya. So kung mag-solve mo, you can put it at different colors if you want. Okay, then what else? Okay, so remember, hay overlap gid siya, kay kung dili mo siya overlap, kung mag-ana lang dili ang F, A ug B, so meaning di siya labot sa forces on B, kay dapat act man siya on B. So our point here is actually representing the block B, so this is incorrect. Okay, so what else pa man? How about yung normal force ni B, kasi si table will also will also like exert a force on B. So this is the normal force on B, but this is actually the force exerted by the table on B. Okay, so that is the free body diagram. That's how you do free body diagram. Okay, so always remember na yung mga forces lang is yung nag-act on the object of interest, na where you decide or based on the problem kung ano yung object na dapat i-compute natin or i-draw natin yung free body diagram niya. Okay, so now before going pa yun sa Newton's application, it is also important to kanang quantify what is friction. So we know friction force is the one who will oppose the applied force or the motion of an object when it is moving. So there are actually two types of friction in terms of mechanics. Okay, so there are many types of friction. Meron tayong contact friction, air friction. Kaya since we are to neglect air friction man all throughout sa mechanics, so we will not talk about air friction. But air friction is also very important also in aerodynamics, or especially in fluid dynamics. Okay, so but again, let's neglect friction. So let's focus only on contact friction. So mga contact friction, so there are two types of friction. We have the static at saka kinetic. So you already discussed this one in your experiment number 4, but I will just review this one to you to understand what really is static and kinetic friction. So a static friction is a friction that keep an object from moving. Okay, so of course I have here a block connected to a string, okay, or a thread here. Then of course, if wala siya motion, at rest siya, we know that nagi po siya forces acting on the body. So we have here the normal force, and we have the weight of the object on the table nga na friction. Okay, so wala siya friction at first of the motion because at rest pa man siya. Remember that the friction only occurs if naa siya applied force or naa motion. Okay? Now, once you apply a force on the string, so remember that the pulling force that you exert on the string is actually the tension. So, even though wala at rest paghapon ang imuhang object, but you exert a force, even though you exert a force, wala gyud siya ni move, actually the one opposing your applied force is the static friction. So from the word static, parang at rest pa yung object mo, static. Okay? So when you pull harder, so as you can see, the tension grows larger because meaning the magnitude increases. So therefore, ang imong friction force would increases, and yung object mo is about to move, meaning about to start na ang motion. So therefore, imo nang na break ang maximum or imo nang na apply ang force nga which equate to the static friction that holds the object and surface together. Okay? So this is the maximum static friction. And then after that, if nag-move na imuhang, say nag-move na siya ang imuhang friction, I mean nag-move na imong object by pulling the force, by your pulling force, then the friction, the type of friction that acts on the motion that opposes the motion of the object, or even the applied force, kasi usually hindi siya always, pero usually yung net force is in the same direction as your motion, 'di ba, the acceleration, pero not always. Okay, so just like what we put in our concept problem. So as you can see here, the friction is in opposite direction as your t, the kinetic friction, meaning that the object is moving na already at constant speed. Okay? So kinetic friction is, again, from the word kinetic, it is when the body is already moving. So siya ang mag-oppose sa motion. Okay? So how can we quantify static at saka friction? So before the object start to move, the static friction force is less than to the mu s times n. The mu s here is actually the coefficient of static friction. It will tell you how much force will you apply to overcome the static friction, di ba? And the n here, the eta nga Greek symbol, the eta is actually the normal force. So the n, some books refer normal force as n lang, okay? So when you overcome the static friction that holds the surface and the object together, this is where the maximum static friction occur. Okay, so which is now equal to mu s times n, where when the object is moving na, the kinetic friction is now equal to this one. Still the same like formula with the static maximum static friction, but the coefficient of kinetic friction is different from the static friction. Okay? So same lang gyapon siya, pero lahi na ilahang coefficient of coefficient of friction. Okay? So yung kinetic friction mo is the one who will tell you nga how much force is needed to make the object move at constant speed. Okay? So dapat equal siya in ani para mo-move lang siya og constant speed. Okay? So in our graph here, this is actually a very important interpretation in terms ato ang motion here, di ba? So at first, wala pang object. At rest pa yung object natin, wala pang applied force. So dito siya, walang tension, therefore walang friction. Now when you try to pull the object by using the spring here, the tension increases, and then the static friction also increases. They will increase. So imo pa jud siyang i-pull until the object is about to move. So here, this is the maximum static friction. Okay, until mo drop dayon siya, then this one represents your kinetic friction force, which is stay constant as long as you are constant speed. So essentially naganaan na siya, pero on average they are constant. Okay, so yeah, the FK and N, as you can see here, na makaingon mo nga, oy, dapat ang imuhang static friction or kinetic friction must be on the same direction as your normal force. But in this case, this is not about vector property, diba? Because we are only talking about numerical values here, that this is actually the relationship between the friction force at saka normal force. And always remember ang normal force always perpendicular to the surface, and friction is always parallel to the surface. Okay, so as you can see here. So generally, yung coefficient of static friction mo is greater than the coefficient of kinetic friction, and these two coefficients are less than or equal to 1 because of the fact that, just like what I said to you sa experiment, di ba, kung siyang gikuan, because it is very hard to move an object that is at rest first than the object that is in motion. So that is why mas dako ang coefficient of static friction. Okay, mas dako imong i-overcome nga friction, okay, to move the object from rest. Okay, so these are the usually coefficient of static friction and kinetic friction of different materials. And again, so this does not matter man gyapon kay because I will just put the coefficient man when I'm talking about getting dynamics of an object. Okay, so mas lindot ni siya if naamot sa civil engineer nga mga student, usually i-memorize nila because these are very important when you know when kanang dealing with buildings, bridges. Okay, so friction is important part of our life. Okay, so we cannot neglect friction in real world because this will uh, mao na ang napadagan sa car, mao na ang nagstay sa atong mga light bulb sa taas ana. So these are not this cannot be ever be neglected. Okay, so even though we assume that friction, some physical system is frictionless, but basically in real world we cannot perfectly or completely neglect the friction because even though ice pa na siya or airflow system sa hockey puck, so these are just to minimize friction, not to completely eliminate friction because we cannot do that in real world. Okay,